Hello everyone and welcome back to another video, and this is kind of a video to show what happens when you have a VRM that is overheating a lot. This is not a graphics card right here, though this has the same circuit that you would see in a graphics card VRM or even a motherboard, like any kind of VRM. This right here is actually my old shuffleboard mixer board, like where I would put my microphone into. The German term is Mischpult. I don't know how to translate it properly. So this is my old one. The one I'm currently using is identical to this one. And this one has a pretty major engineering flaw that I only now discovered because I saw a YouTube video of someone repairing a pretty similar board to this from the same manufacturer. And it had the same problem that this one has and the one I'm currently using also has. And that is the VRM of this thing is overheating a lot. And that's, it's not blowing up or anything, but it does kill the thing after a while of using it. So the thing we care about here is this part. We have our three MOSFETs over here. Here's your input filtering and here's output filtering. And what I'm going to concentrate on is the input and output filtering, the capacitors. And if you look at these, they do look completely fine. Like none of them are blown up, they're not leaking, but these capacitors are very much very dead. These are no capacitors anymore. These are basically just not there as far as the thing is concerned. Now on a graphics card, you would have your input filtering here, your output filtering here, but essentially it's the same thing. This, by the way, is the RX 170 that I'm kind of a sneak peek for the next thing I'm doing. Yeah. So the thing is, the VRM on this thing, this is the heatsink for it. You can see there's a bit of thermal paste or something. It's kind of pasty. Yeah, some cheap looking thermal paste. And this heatsink literally is just screwed onto these. I've bent these out slightly to get a better look at them. But there's like 3 screws through these holes, and then it's attached like under this. And this is a very cheap piece. I'm actually not sure if it's even aluminium. It's metal. It does conduct heat, but it does so very poorly. And these MOSFETs, I plugged this thing in. This is, by the way, not the original connector. The connector I broke at some point, so it had to be replaced by this. But I plugged this in for 20, maybe 30 seconds. And the MOSFETs, and generally the entire area of the VRM, got so hot I couldn't touch the board anymore. It's not like, ooh, it's pretty hot. It's like, yeah, like you get burned, basically. So this heatsink is useless. You can just throw that away, and I think I just flicked a MOSFET off my desk. Hopefully I don't need that. Yeah, and this, it still kinda works. The VRM does work. Like, I don't know what goes in. These input filtering caps are like 100 volts, even though the power supply for this puts out like 18 volts or something. I don't know. I don't really know what voltage this steps down to. I know there's a plus 48 volt rail on this for the microphone, because my microphone does need plus 48 volts. Like, I think there's like maybe 2 voltage rails on this. Like the power supply is basically just a transformer, so this is, I think, AC power that's going. I actually don't know. I haven't looked at the power supply in like years. I took it apart once because first I thought the power supply is broken, but it wasn't. Thing is, the thing that I'm really want to talk about here is something that this has definitely in common with any kind of VRM that you have, and that's heat. that it produces. On the YouTube video that I saw, you were actually able to see how the PCB around this area darkened. On this one, like this piece of paper is glued on there, kinda, but like there's no discoloration here. I've used this for like 2 years, 3 maybe. The board that I have now is coming up on 2 years. And the board that I have is like there is some background noise. You can always hear a bit of background noise in the videos. This wasn't there at the beginning when I got this board. So yeah, whatever issue killed this thing is also starting to become a problem on the board that I'm currently using. But this board has a much bigger issue, and let's talk about that. So when I plug this thing in, like all the knobs still do what they are supposed to do. Yeah, all the buttons still work. It still powers on. The problem is the output. Like if you take this USB port, you plug it into your PC. The output has extremely loud and annoying noise, and that noise is perfect 50 Hertz. Now, since I live in Europe, my power outlet, my 220 volts, 230 volts, I think 230 volts, has a frequency of 50 Hertz. That's the AC power frequency that my power outlets have. Now, why am I hearing that frequency on my microphone and the output? Because those capacitors, like there's some sort of AC power going in here, like I don't know what the wires are doing. Again, like, I don't know. I'm pretty sure this is like this VRM. There might be a rectifier somewhere in here turning AC into DC. The thing that I'm talking about is the capacitors. So these capacitors are supposed to filter out the noise that's coming from here, like that's produced by the AC. Normally these capacitors do that. On this board they're no longer doing it. On my current board they're starting to not do it anymore. They're still working, but like they are becoming less and less efficient at it. On this board they're completely dead, like completely fully dead. These capacitors don't do anything anymore. And that's because of heat from the VRM. And that happens to motherboards and graphics cards too. So these capacitors, most capacitors you have are rated for X amount of hours at 105 degrees. I think it's universally 105 degrees. And then X amount of hours. So on cheap motherboards and graphics cards you get like 2000 hours. Sometimes you get 5000, 8000, sometimes even 10,000, though those are pretty rare. And the thing is, the temperature is really important, because a 2000 hour capacitor at 105 degrees, well, that's gonna be good for 2000 hours before it begins to fail. And 2000 hours is not that much if you consider that as long as the VRM is running, that time is counting down. The thing is, a 2000 hour capacitor at 80 degrees, not 105, will hold for like 6000, 10,000 hours. They will hold a lot longer if you keep them cool. And yeah, since most VRMs don't bother with like super high endurance capacitors like 8 or 10,000 hours, mostly get like 5,000, 6,000, sometimes 7,000. The VRMs have to be designed around those capacitors not dying within the time you would use your device, which like I kept my 780 Ti for over 4 years, and the capacitors on that thing are actually still okay. So yeah, on this thing, like this is a pretty cheap one. This thing cost me like $100. This is pretty cheap. You can get cheaper than this, but like this is pretty much the cheapest thing you can get with like this integrated sound processor. Like there's some effects that this can do. So as it turns out, the manufacturer of this used capacitors that are very, very cheap, and they do not do well with high heat for an extensive amount of time. Or maybe these are pretty good capacitors, they're just running so hot that, well, they die after like a few years. That's probably a couple thousand hours of use, considering this thing is pretty much always running when my PC is running. And yeah, so the VRM on this thing got so hot, the heatsink is doing like, this thing is obviously not open on my desk. There's a casing around this, and the casing has no connection to the heatsink. There is just a very small, like a few slits for air where the heatsink is on the underside. But the metal casing around it has no physical contact with the heatsink. So the heatsinking of this is very, very underpowered. And that's true for my current one as well. So I tried some things to fix this on my current one. What I did is just I removed the bottom of the casing and put it up on a stand, so it has like 2 or 3 centimeters of air under it, in the hopes that this will help the heatsink at dissipating the heat. If I touch the heatsink, I get pretty much burned instantly. I can't tell if it's helping. But yeah, this is what happens when your VRM gets too hot. You kill your capacitors. Because like your MOSFETs and all that other stuff, your driver chips, your controller chips, these are often rated for 150 degrees. Which doesn't mean you should have them at 150 degrees, it's just they can operate at that temperature. They will still degrade a lot, like MOSFETs, and can also degrade and break over time, and heat makes that worse. But the thing with the least temperature tolerance in your VRM is always the capacitors. And you want to keep these, well, that's pretty much an arbitrary number, but I would say keep these at least 80 degrees or lower. Because, well, when I used this thing, I actually didn't use it. I don't actually know. I don't know how my usage was of this thing. This is very, very old. But like it took like 2 or 3 years after I got this for it to like break so much that like every time I used my microphone for anything, you had a very strong 50 hertz noise. And that's, well, pretty annoying. And that noise, that 50 hertz, is pretty much what also happens when your capacitors in your graphics card or motherboard VRM dies. There's noise. There's noise coming through. The capacitors are no longer filtering out noise. In this case, literal noise that you can hear. In terms of a graphics card, if these capacitors would die, well, you're gonna get a lot of switching noise, which is, instead of getting more precise, like there's always switching noise from a VRM, but more capacitors make that better. So let's say you have a VRM that puts out a voltage with an average of 1.2 volts. And let's say at stock, like with the ideal capacitors, the noise is like plus minus 100 millivolts. So you have a maximum of 1.21 and a minimum of 1.19 volts. Without the capacitors, there's going to be more noise. So maybe suddenly you have a minimum of 1.15 and a maximum of 1.25. Now you have literally 100 millivolts peak-to-peak voltage instead of 20 millivolts, which 20 millivolts is pretty... that's wishful thinking. I think graphics cards usually have a lot more than 20 millivolts peak-to-peak, but 100 millivolts is already pretty bad. And the thing is, here it completely ruins your sound. On a graphics card, this completely ruins your stability. And if it gets bad enough, if enough capacitors die, the card won't even run stock anymore. Like it will just crash at stock speeds, because the switching noise gets so bad that you have, sometimes the voltage goes as low as, let's say, completely worst case, 900 millivolts, and someone's mowing their lawn outside. Great. I hope this is not too annoying. But this is about how bad the 50 hertz thing got, at least from how I'm hearing it right now. I don't know how it picks up on the recording. Yeah, so the thing that happens on, say, a graphics card is if your switching noise gets bad enough, because your minimum voltage is what is, that's what affects your maximum overclock, because if your voltage goes down to something at some point in time, well, your card has to be stable on that amount of voltage. It doesn't matter how much higher it goes. If you have a certain minimum, when you have that minimum, that's the voltage your component has to run on. If there's more than that, it doesn't matter, because it will crash the moment the voltage goes low. And with less capacitors, not only your high, but also your low voltage gets worse, which the high voltage, that can, when it's really, really bad, potentially degrade even if it gets really, really high. But the main problem is your low voltage will get too low for your card, or your CPU, generally everything, to hold stability. And that will make your overclock worse, and if it gets bad enough, you will no longer be able to run stock. And that's why you want to keep your VRM, specifically your capacitors, cold. You don't want them to run hot. You don't want them to degrade. You don't want them to be as bad as here, where they're literally no longer there as far as the electronics are concerned. There's no more capacitors on this thing. The 50 Hz just gets right through. And yeah, whereas here, this makes this entire thing completely useless unless I recap everything. Your graphics card. This makes your overclock worse. And the complete worst case, someone who doesn't know about all this, they have a card that has like a very hot running VRM, which can happen. This one, for example, is running extremely hot. They're gonna have a graphics card, and after a few years, it just crashes. Like, let's say someone who doesn't overclock their card, who doesn't know about all this stuff. They have a card, and after a few years, it just crashes all the time, and they're like, oh, it's broken now. Card is broken, and they're kind of right, because the card can no longer operate as it was designed to do. But as far as the card goes, the main components are completely fine. It's just your capacitors have degraded so much that they're no longer there. So in that case, just putting on more caps or replacing the broken ones, you're gonna have a completely working card. And I think a lot of graphics cards with overheating VRMs get lobbed into the trash bin because of this very reason. Like, pretty much every graphics card you find on eBay that says crashes after a few minutes is either overheating on straight up the core, or the VRM is overheating so bad the capacitors have degraded and it can no longer run stock. Both of these are pretty easy fixes if you have the components and the equipment. So yeah. And that's pretty much what I wanted to say. Well, this turned out longer than I thought. I thought this was just a short, this thing is dead. I'm gonna tell you why it's dead and why it's bad to have the thing happen that kills this, which is... well, what just happened? I saw the picture freeze on my smartphone. Hope the recording is okay. Yeah, so don't have your VRM overheating, because while your MOSFETs and all your driver chips and all that may be okay, your capacitors are going to get steadily worse. They're going to degrade over time, and then someday you will see either your overclock crashing, or if it gets bad enough, you will see your card no longer running stock. Which is exactly what the 3080 is doing right now, because the 3080, the cards that are crashing, have a subpar capacitor layout, where basically the capacitors that it comes with are so bad that basically they act the same like a good card that has degraded capacitors. And you see what's happening there, because that's the exact same thing, just without the degradation part, because these are too bad from the beginning. Yeah. And... why are we really coming up on 20 minutes? Yeah, I really didn't want this to be another 20-minute video. I think I've said everything I wanted to say. So thank you for watching, hope you enjoyed, and until we see each other next time. Goodbye.